Now let's find the values of a, b, and c for our partial fractions. Okay, let's use this for this example. You have this fraction. What you have to do is first realize where are the roots. It is real roots different, all different, so you don't have repeated roots. And the roots is equal to 2, minus 2 for this, and equal to 3 for this. So in this case, the partial fractions are like this. A over s minus 2 plus b over s plus 2 and plus c over s minus 3. Alright? So now what we are going to do right now is what are the values of A, B, and C. Okay, now this is the procedure. I'm going to do a classical procedure, and then I'm going to give you a more easier method to find the values of A, B, and C. But let's do the common approach. Okay, what is the common denominator of this? The common denominator is s minus 2, s plus 2, s minus 3. That is the common denominator. Okay, if you do these three fractions. So when you do common denominator, you will have to do this. This divided by this times the a. So this divided by this, the s minus 2 cancels, so you will have a times s plus 2 and s minus 3. Plus, now this divided by this times the b is going to be b plus, what cancels here is plus 2, so you will have b times s minus 2, s minus 3, plus c. Now this divided by this, the s minus 3 cancels, so it's going to be c times s minus 2 and s plus 2. You usually do this a times the other two, b times the other two, and c times the other two. Okay, that is the fraction. Okay, now what the purpose of this is that these partial fractions to be equal to this fraction. So that means that when you do the common denominator, this must be equal to this. As you can see here, the denominator is already the same. What you need to make the same is the numerator. So what is the numerator? The numerator is 7s minus 2s squared minus 4 equal to a s plus 2 s minus 3 plus b s minus 2 s minus 3 plus c s minus 2 s plus 2. Okay, so those are the numerators. Okay, now here comes something that I call the magic numbers. Now, to make this easier, I'm going to choose s1 equal to 2. What is the advantage of taking s equal to 2? Well, if you do that, then what happens here is that if you replace s equal to 2, here is going to be 7 times 2 minus 2 times 2 squared minus 4. And that is equal to a times 2 plus 2, 4. 2 minus 3 is going to be minus 1, and that's it. And what happens to the others? This is 0, and this is 0. 2 minus 2. So what you have 0 and 0 here. So what happens here is that the values of b and c, they are cancelled, and the only one surviving is the value of a. So what is the value of a? The value of a is equal to, well, this is 4a on this case, minus 4a negative. And on this side is going to be 14, and then 2 squared, 4 minus 2 is going to be minus 8, and then minus 4. So that makes minus 4 and minus 8 and minus 4, minus 12, plus 14 is going to be just 2. So the value of a happens to be just minus 1 over 2. That is the first value of a. Now, what happens if you choose s equal to... Now, why did I choose s equal to 2? Because they happen to be the root. And because this happens to be the root, that is why this becomes 0. So that helps to just have one variable. Okay, now let's choose the other root. s2 is equal to minus 2. What happens in this case? Then you will replace here 7 times minus 2 minus 2 squared, and then minus 4 equal to a times 0, because this minus 2 and minus 2 plus 2 become 0, plus b minus 2 and minus 2 minus 4 here, and then minus 2 and minus 3 minus 5 here, plus the value of c. So here is going to be 0, minus 2 and plus 2, 0. So this, well, they don't cancel, but they don't care about this calculation. So what you have here is 4 times 5 is going to be 20. 20b is equal to how much? Minus 14 over here, minus 8, minus 4. So how much is that? That is equal to minus 18 minus 26. Alright? Minus 26. So the value of b is equal to minus 26 over 20, and that is the value. You can reduce the number, but the important thing is to find the value of b. Okay, now, what if you happen to use the third root, s equal to 3? S equal to 3, so what happens? 7 times 3 minus 2 times 3 squared minus 4 equal to what happens here if you use s equal to 3, so this becomes 0, a times 0, this becomes 0, b times 0, plus the value of c, 3 and minus 2, 1, and 3 plus 2, 5. So what you get is 5c is equal to, the numbers here is 21 minus 9 times 2 is going to be minus 18, and then minus 4. 21 minus 18, that is 3 positive, minus 4 is going to be equal to minus 1. So the value of c is equal to minus 1 over 5. Alright, assuming that I don't have any mistakes. Okay, so the partial fraction will be something like this. A minus 1/2 over s minus 2 plus, I am replacing the values here. The value of b is minus 13 over 10 if we make the half, s plus 2, and then plus the value of c minus 1 over 5 over s minus 3. Okay, so that is the procedure to make partial fractions, and then you will have the formulas to make this calculation of the Laplace inverse. But I want to use another method, and that method is called the Heaviside method. And then you can skip some steps here. It is a very easy method to use. Now check this out. We are going to calculate the value of a very easy. A is going to be something like this. Okay, now check this. A is divided by s minus 2 here. So on this fraction, the value of a is this fraction, but you remove s minus 2. It's going to be 7s minus 2s squared minus 4 over s plus 2, and then s minus 3. And then you replace the value of that root, which is 2. So it's going to be 7 times 2 minus 2 times 2 squared minus 4 over 4 here, and then 2 minus 3 minus 1 here. So what is the value of this? Actually, this value is already here, is 2. So this is 14 minus 8. So that is, and then minus 4. So that becomes 12. And that is going to be 2 over minus 4. Okay, so that is equal to minus 1/2. Okay, and you get it, which is the same as before. Okay, I hope you use this method, it's very easy. Now, the next value, the value of b. For the value of b, as you can see, b is divided by s over plus 2. So on this fraction, you cancel s plus 2, or you just remove it. 7s minus 2s squared minus 4 divided by s minus 2 and s minus 3. As you can see, you just remove the s plus 2. And then you replace the value of s equal to minus 2, which is the root. So it's going to be 7 times minus 2 minus 2 minus 2 squared minus 4 divided by minus 4 here because it's minus 2, and then minus 5. Okay, so what is the result? The result of this is, in this case, is 20 positive here, and in the numerator is going to be, if we do the calculation, which is the same as this, all right, minus 4, and that is equal to minus 26, and that is equal to minus 13 over 20, which is the same result as before. So you can see it's very easy, this method. I'm going to do the last one. The last one is c is equal to, the value of c is, for c is divided by s minus 3, so you remove s minus 3, so it's going to be 7s minus 2s squared minus 4 over s minus 2 and s plus 2. And then you replace the value of s equal to 3 because that is the root for the c. So it's going to be 7 times 3 minus 2 times 3 squared minus 4 divided by, here is going to be s3. So 3 minus 2 is just 1, and 3 plus 2 is 5. So it is divided by 5, and this number is actually this very same number, so that is equal to minus 1. So it is minus 1 over 5, which is the number that we just calculated here. So the partial fractions will be, so as you can see, this is a little bit longer, but this is the same result, and this is a short method because you just use this part to get these numbers of a, b, and c. Now, be careful, engineers. This only works with the real roots. When you have repeated roots, it works partially. It doesn't work at all. You can find some values of some of the constants. And for the imaginary number, it also works this method, but you have to deal with imaginary numbers. So be careful on that. Next video we will see real repeated roots case to find the values of a, b, and c. See you on the next one.